Good morning, good afternoon, good evening.
Assalamu alaikum.
Wa alaikum salam. By the way, is there a good, like 2 in the morning? There's a good morning, there's a good afternoon, good evening. What about the other? There's lots of the part of the day that's not represented there.
Yeah, I guess. I
How
mean,
about in Arabic?
even if you look at it, well, Assalamu alaikum is going to work for any time.
Yeah,
That's the
yeah.
thing. Um,
But
but
like, but in Arabic, you have the good morning, good afternoon, good evening, right? Sabah al khair,
yeah,
sabah al nur. Which one is that? I don't even know.
no, you can say also Masa al khair, good evening.
Yeah, there's other variations. Yeah. But the point is, not much of the day got represented in those. Good something.
Yeah,
I guess
but
we don't. I guess we don't want to see each other at those other times.
yeah. Well, there are other markers that you have for the day. You have the prayers that basically mark the time. But this is not a greeting as such, but it's an expectation that you're going to be getting together at
Yeah.
those times.
All right. Let's tell some people why we're here. This is Deconstructing Islam, a weekly live stream where Usama and I help those struggling with Islam, and we help the outside world better understand us. This live stream is part of Uniting the Cults, a nonprofit to rid the world of apostasy laws. We have a manifesto, and we're dropping this one actually, and instead doing the one that Maryam Namazi started 4 years ago, which I didn't know about. It's called August 22nd, Apostasy Day.
Yeah,
that's the name of the manifesto. So I actually like better that the title has the day in it. Anyway, the link is in the description. Join us June 14th for the first anniversary of Uniting the Cults. We'll be talking about the goals, the progress we've had over the past year, and next steps. And I'll be joined by Maryam Namazi, Wissam Sharafuddin, Apostate Alauddin, and Zara K, and maybe Usama El-Binni.
yeah, we'll see.
By the way, I sent you the list of all the notes.
Oh yeah, okay.
Yeah. Let's see. Follow us on X, Reddit, TikTok, and we've closed down the Discord. Maybe we'll have one in the future. I want to talk to. I kind of want to wait till more people actually want to help too. Like, not just want to be joined, but want to help.
I didn't know that there was an activity on TikTok. Do you post videos there?
I do. Yeah,
I don't have an account to begin.
Yeah,
with.
I do. Yeah. What I learned about TikTok is that it's, out of all the social media, it's the one that can let something go viral, even if the user is a nobody.
Yeah, I've heard about something getting millions of likes for, I don't know, someone just sneezing or.
Yeah, there's a lot of. What's interesting is they increased their time limit. It was when it came out, it was the one that's the shortest. I think it was 30 seconds or something. But now they max out at 10 minutes.
Okay.
And some people use all that. And I've seen some really long videos, which were really good. But I guess they use it differently.
It's designed for people with very low attention span, and that's what I'm guessing that's the 30 whatever it is that you had at the beginning, and then it started increasing.
Yeah, well, it's still used like before. I don't really know. I don't pay attention too much. Part of why I even knew anything about it was that my kids, if I didn't have kids, I'd be like, TikTok, what the fuck is that? Stop telling me this new shit.
Yeah, I don't
know. So please leave your questions and thoughts in the chat. We'll try to talk about it. We'll try to prioritize people that are trying to learn, asking questions, or giving us criticism, helping us learn. We would like to do call-ins, but I don't know if these next few episodes make sense. Maybe towards the end, if somebody has some questions about what Usama is going to be presenting today.
Yeah. I mean, the fact that the topic itself is a very intriguing topic probably means that there are going to be questions, but I don't think just injecting the questions within what we're doing is a good idea.
That's why I say at the end of every episode.
Maybe what can be done is to collect as many of these and then treat them as a Q&A or something.
Yeah, that would be good, especially for this kind of for this kind of day where this day seems at least as structured as any of the previous episodes we've done, where sometimes we kind of wing it. Last episode, I should tell you a little bit about it. It was me and Zorro. It was really good, man. And I liked that it was two non-experts talking about this because I want the audience to see, because they're non-experts, right? I want them to see two people who don't know much about it, how they think about it.
Let me say a disclaimer then. I might be a physicist, but I'm not a cosmologist. So
right. That's another good point to give people. You're also not an expert if we're talking about, among physicists.
Yeah. So this is not my specialty, but it does overlap in certain areas. And
let's talk about the schooling. So I did a bachelor's degree in physics, and I actually can't remember if we ever talked about the Big Bang. I don't think we ever did. I think everything I know was outside of the context of my schooling. So how about you? You did an additional 5 years. What did you hear about Big Bang in those 5 years?
Well, I did more than 5 years actually, because
you did more than 5-year PhD.
Well, no, I first had a master's and then I did a PhD. So
so I don't know how that stuff works. If you got your master's and then you go get a PhD, your 2 years don't add up. Like, you have to do another 2.
No, the nice thing about that is that by the time you get to the PhD, if you already had some classes, you get to skip them, which means that you can focus more on research.
But you're still doing that 7 years after bachelor's degree.
Something
like that.
Yeah. So it's amounted to a lot of years. Let's say it this way.
So you got a bigger school loan.
Well, fortunately, with graduate schools, that's actually not an issue.
Okay, I don't know what that means.
Okay, I mean we can discuss that separately, but loans usually fall on undergraduates, not graduates, because what happens to graduates is that you can actually serve the university, and that can give you a way to either reduce or to completely remove the tuition fees.
And then some people aren't doing that, so they're doing the whole loan thing.
It's very rare that you see that.
Yeah.
Almost all graduate students have some form of teaching assistance, research assistance, some form.
So by the way, everyone, if you're thinking about what job you can to go plan for, to go to school that is going to be protected against AI, go become a physicist.
So far maybe, but there are certain areas where AI seems to be encroaching. So I can think of one example where it's actually doing research in biology, and what happens there is there was an AI that was let loose on essentially an archive of the most recent papers, and it was asked about, what do you think the next step is going to be? And it pretty much came up with a paper that coincided with another paper that was written by researchers who have been working on this for quite a while. So AI is formidable also when it comes to research.
Man, you're just gonna scare the shit out of people with this.
but let me say something about physics. So the other day I was writing an exam, and what usually happens is that we give it to a teaching assistant to proofread and to solve, to just see if there are issues. So I gave it to ChatGPT. It was okay with some of the problems. One problem had a diagram, and it way off. It had absolutely no idea what it was doing. So it still requires a lot of improvement, especially in situations that involve visual analysis, diagrams, and things of that sort. And if you look at the way that it actually adds numbers, it's really so scary and bizarre. You wouldn't even think that this is math. Adding 1 plus 1 equals 2, it actually uses language models as such. So it looks, for example, at how 1 and 1 are correlated in texts, and what's the probability of them being correlated with some other number. And it's not actually adding 1 plus 1 to get 2. It's just looking for these correlations.
Yeah, it's interesting how it's doing that. It's almost like it's doing intuition like us, except
Yeah.
I can still use both. I have intuition, and yeah, like you give me some kind of something that asks for a number, and I can use my intuition to get a number that would be in the ballpark.
Right.
But I would still do math, and what we're finding is ChatGPT will do the intuition, but not the math.
Well, I wouldn't even call it intuition as such. That's probably too generous. I would call it pattern recognition, probably.
Okay.
But in any case, I think there's still a long way for it to go before it can do proper physics. But I'm not holding my breath. This is something that's going to be happening at one point or another.
All right. So, do you want to get started on today's topic?
Yeah, sure. So maybe before we can do that, in order to have some kind of a connection with what you did last time, because I just looked at the first
Yeah.
couple of minutes. I didn't have the chance to watch the whole
What we
thing.
talked about is, well, the way we envisioned this episode was to talk about the Big Bang, but not only from the context of physics, but also theology. And we barely talked about the physics, just a few things that I thought of as we were talking. Mostly the theological side is what we were talking about.
Mhm.
And you know, even broader things like I remember at one point, I'll never forget this now. This keeps popping up in my head. Towards the end of the episode, Zorro was talking about how when we meet, when he meets up with what he called an educated atheist, he said they'll agree on everything.
Yeah.
And what we were saying was believing in God keeps us separated. And then he goes, 1 plus 1 equals 2. Why are we arguing? He was describing two educated atheists, I guess, or you know, if we were to even say anything, if we were to disagree on anything, 1 plus 1 equals 2. Why are we arguing about nonsense? Arguing about nonsense.
Yeah. Well, I think that's true and not so true when it comes to, especially if you have open questions. The people who tend to disagree the most would be the people who have a lot of things in common. I think we talked about that before in the context of sects, where you have Sunnis and Shiites. They're going to be fighting over really particulars compared to Shiites versus, say, Christians, where you have a completely different theology.
Isn't that more so of noticing our disagreements and exposing them and talking about them, as opposed to not really noticing our disagreements, or maybe noticing them a little bit, but then hiding them? You know, there's a thing people do in social engagement scenarios where, and it's kind of like a type of person too, where they, if they find a disagreement with each other, they're like, oh no, we're disagreeing, change topics.
Yeah, but
then you never really see the disagreements.
That's true, and that actually brings up the question of when is it that you're going to actually have a disagreement if people are similar. You have to have something in stake, something that actually matters, that people are trying to talk about, and it probably has to be controversial enough that you're going to start thinking, okay, we have so much in common. Let's make sure that we get this settled. But yeah, there has to be something important that needs to be resolved.
So, and by the way, I don't even remember what we talked about, because I just remember it all being very general. What I could do is quickly look at the timestamps um, history of ideas, the role of contradictions. Look how general that is. Life is learning. Life is a series of experiments. Big Bang and relativity will be replaced with a better theory in the future. We discussed our education that led to us being able to do these things. And that's it. So and again, we did talk about Big Bang a little bit, just a few things here and there, and they're all things that you and I have talked about before. It's my amateur levels understanding of Big Bang. So
Yeah. So then once again, I'm not a specialist, but yeah, I did actually get some exposure to cosmology in coursework, but not in research. Even though some of the research does overlap with things that I did. So when talking about particle physics and black holes and physics beyond the standard model, it eventually is going to overlap with cosmology. And the reason for that is because when you're looking at the Big Bang, as we'll see, it's talking about constraining matter to a very small space, which is typically what you would expect if you're talking about what is usually referred to as the singularity in the context of general relativity. And as a result of that, if you're talking about a very small space with a lot of energy, you have to also invoke quantum mechanics. And so this has a lot of overlap, but again, it's not quite the same thing. Yeah, so of course it's a very important topic, because when you're looking at the history of the 20th century cosmology and how it started and how it ended, you start with a discipline that basically has no quantitative science. I mean, there was astronomy, there was astrophysics, but there was no real cosmology. You had a lot of speculation, and it wasn't until the models that we had that were competing in the first half of the 20th century, Big Bang theory and steady state theory, that there was enough experimental evidence to say that one of them is right, one of them is wrong.
So maybe you're getting to too much details already. Tell people what the steady state theory is, which it predates the Big Bang theory, right?
Right, and it's pretty much what you would expect if you're looking at the scale of things beyond Earth and looking at what we perceive of the structure of the universe, which is essentially what you would get from the movement of stars.
So in steady state theory, does it say that galaxies form versus they already exist?
Well, if you go back to that time, people didn't even know that there was a second galaxy to begin with.
Oh.
It was.
That's how far back we're talking about.
Yeah, we're thinking beginning of the 20th century, people thought that there was only one galaxy. It was our galaxy, and it was called basically an island universe. And other galaxies, you can see them with a telescope, but it wasn't actually known that these are
those are galaxies versus just stars.
Exactly. So you don't have enough resolution to begin with in order to distinguish them. And it wasn't until telescopes improved enough that it was possible to start seeing some detail, even though if you look at the closest galaxy that we have to us, the Andromeda galaxy, if it's actually bright enough, it would be as big as the moon in the night sky. It's really that big. But there's not much light getting through to begin with. You have to have a good telescope and so on. But right now, with a decent telescope, it's possible to really create a lot of high resolution pictures. Well, high resolution depending on how you define it for many of these features, and to actually see that this is not just a single star, but a whole structure. And so with the steady state theory, there has to be some form of an accounting of what's actually out there, and how is it that there are certain paradoxes that you have to deal with. So one of the most famous paradox, and this was actually already dealt with by a Greek philosopher, I don't remember his name right now. If you look at the night sky appears dark. A steady state universe that's basically infinite in size, that doesn't have any particular structure, should have an infinite number of stars. And if that's the case, no matter what, how far they are and how faint, you can actually show that you can compensate for distance by density. You can actually expect that we would be burning because of how bright the night sky is supposed to be, but that's not the case.
Did they realize that implication?
Yeah. So this kind of initial implication that if you have an infinite universe, which is the basis for talking about a steady state universe, you should have an infinite number of stars. If you assume that all the regions
are also infinitely far away, so that would reduce the intensity.
Yeah, the problem here is that this is going to go as so. Here's the thing: the intensity is going to go as 1 over r squared. It's going to go inversely with the square of the distance. But the distribution of the stars, if it's uniform, is going to go as r squared. So they're going to cancel exactly each other, and you're going to end up with the faintness completely compensated for by the increase of density as you're increasing the cone.
Well, I'm not following your math, but okay.
Okay, it probably requires a diagram to show this.
Yeah.
I should have included a couple of diagrams here.
Should I write that down? Is the thing people care? I don't know. I mean, that's what we're doing, is analyzing the static universe theory before the Big Bang. I guess we don't need to. We already know it's nonsense.
Yeah, and there are several contradictions that could tell you that the steady state universe is actually not viable, even without doing any observations. That's one of them. I mean, observations in the sense of going out and making. Do
you want to explain this part about Einstein when he came up with relativity? He wanted static universe.
Yeah, because like I was just explaining at the time, this was the expectation of what people observed. They weren't actually seeing something like the observations that we subsequently see, like by Edwin Hubble's idea that there's an expansion of the universe. This wasn't something that was known at the time, and so what he ended up doing was, if you look at the equations of general relativity, the ones that govern the expansion of the universe and govern gravity and so on, all these phenomena, in order to stabilize it and to prevent any kind of collapse into black holes or creating these this instability, he inserted what is known as the cosmological constant, and he thought, like maybe we talked about that before, he thought that this was the biggest blunder of his life, because after he was convinced that the universe is actually changing size, that it's expanding, that this stability, this force stability, wasn't actually something that should be there. But on another iteration after that, people discovered that the value of this constant can also account for what we're seeing right now, which is that the universe is expanding and accelerating. And so its value would account for what we typically call right now dark energy, which is basically an energy that's accounting for what can be considered as repulsive gravity, if you will. That's pushing the universe to keep
pulling the universe apart, which is kind of like opposite of gravity.
Exactly. And so when looking at the steady state theory at the time, there had to be some kind of a mechanism for generating continuous matter, essentially, in order to ensure that even if you have expansion, something is filling up that void that's going to be created. And so in steady state theory, they basically came up with this hypothesis that matter is continually being generated. How is it generated? Nobody knows, but it's generated. There were some proposals to account for that, but nothing actually
So
made sense.
help me understand something. E equals mc squared. I don't know too much about it. It comes from relativity, and something that it implies is energy can be converted to mass, and mass can be converted back into energy.
Yeah.
So, with that in mind, what does that mean about how to think about the Big Bang event?
Well, the Big Bang event was so energetic that we're not talking about mass at all. It at the time, it wasn't possible to have any kind of atoms, for example. The
So
temperature.
it was pure energy right at the start, no mass yet.
Yeah, you ended up with a soup of particles, essentially, that contain the electrons, the protons, even the photons. And so there is a barrier, essentially, that prevents us from seeing with visible light. Beyond that, this accounts for about 300, 400,000 years after the Big Bang, because beyond that point, you have that opaqueness where photons are trapped in this soup and they don't escape to the outside. So you have when you're looking at the background radiation that we see right now, the CMB, the cosmic microwave background radiation, you're only able to see up to about 400,000 years after the Big Bang, but you're not able to see with visible light beyond.
Tell people how they can see the cosmic microwave background radiation.
Well, if you have an old school TV,
Isn't that shitty? We used to have the technology and now we don't.
yeah, about 10% of the static that you see, if there is no channel broadcasting, about 10% of the static is coming from that background radiation.
And the rest is other stuff happening on Earth.
Yeah, I mean, you have all sorts of noise that's coming from everywhere. And so combining all this together gives you that static that you see when there's a channel that doesn't have any broadcast on it. And I think maybe we have talked about how
we're skipping ahead. I notice here.
Yeah.
We're talking about the CMB now. And how is this the smoking gun? I don't know about this.
Right. So at the time, something like the steady state theory, when you're trying to come up with predictions from it, it's not easy to have it account for, especially for something like the expansion of the universe. Whereas Big Bang theory, starting with Lemaître and then after that Gamow, they started making mathematical description of what the implications are. One of the implications is that you're going to have residual energy that's going to be pervading the entire universe. And once equilibrium is reached, like any kind of system where when you have equilibrium, thermal equilibrium is reached in a system, the temperature is going to be constant. And this means that if you were to look anywhere in any direction in the universe, you're going to see a radiation. They expected that this is going to be in the microwave region. And I believe at the time they expected that the range, they were doing theoretical estimates, of course. They were expecting that the range is going to be 5 kelvins. That is to say 5 degrees in the Celsius unit above absolute zero.
Yeah, so that's to tell people how cold that is. We are sitting at 270 Kelvin temperature. And 0 Kelvin is a theoretical no energy state with no vibrations,
Yeah.
which I think we talked about this before, and you said that's not even possible. It's a
Yeah.
theoretical thing that's not even possible. And we're saying the calculation they made for what they expected the background radiation to be coming from the beginning of the universe, the Big Bang, is 5 Kelvin, which is very cold.
Yeah, it's very cold, and the order of magnitude of this is important because the actual observation that ended up being measured, and you can right now devise various. It was about 3 degrees, 2.7.
3 Kelvin.
Yeah.
So we predicted 5 Kelvin out of a range of, well, here, give people the other side of things. The center of the sun is something like, is it 5 million Kelvin?
Yeah. I mean,
so that's a range, right? And there are stars that are hotter than that, right? Mm-hmm. I wonder how much hotter. Do you know that? What is like the hottest?
I can't name a number off the top of my head.
Is it orders of magnitude bigger than the 5 million, or just a little bit bigger?
Well, what I can tell you is that on Earth we can actually reach temperatures that are colder than space and hotter than the inside of the sun.
We can reach above 5 million degrees.
Yeah. If you're trying to do nuclear fusion experiments, you have to reach really hot.
And we have done some nuclear fusion. It's just not sustained.
And
we only do it for like 20 seconds, right?
Well, I don't know the limits of the technology right now. It's supposed to be something that you can use in order to generate power. So
if they achieve it, yeah. But they're running tests and stuff, and they have we've done it for 20 seconds now. I think I recently saw the record is like 20 seconds or maybe 30 seconds.
Yeah, I'm not following right now the technology on this, but yeah, they're
so that would be the temperature of the inner part of the sun, 5 million degrees Kelvin. On the low end, here, the outside of the sun is 10,000 degrees Kelvin.
About 6, I think.
6,000 degrees Kelvin?
Yeah.
And then much further from the sun, we're pretty far away. I don't know how far away. It's in range of 270. That's like room temperature for us. If you go down,
but we have to account for the atmosphere.
Okay, go ahead.
No, if you account for the atmosphere, that's going to give you a completely different picture. Because, for example, the surface of the moon without an atmosphere can get really, really hot or can get really, really cold. You have a
the atmosphere acts as a buffer. It brings the low side a little bit higher and the high side a little bit lower. But anyway, so on Earth, what is the coldest thing on Earth?
Well,
I mean, naturally, without us trying to make it colder.
Well, naturally, I don't think naturally it's going to be that impressive. You might go to a place like Antarctica, and it might go to 80 below 0 Celsius,
which is 190 Kelvin, or no, plus another 25. So I think 215 Kelvin or something.
Yeah. So in natural systems on Earth, you're not going to get really that cold.
Yeah, and okay, let's say this part though. I don't know where they learned this, but like far out in space, far away from things, how did they know that? I always heard that's like 4 degrees Kelvin. Is that from this number right here?
Well, you can measure different temperatures of very far away places. You can basically just point a telescope and measure the temperature. So there is, if you look at the distribution of wavelengths of any light that's coming in, you can actually figure out the most dominant light or wavelength that's there and figure out the temperature from it. So we're able to measure the temperature of hot things on Earth, for example, using this technique without actually necessarily poking a thermometer there. And you can then poke a thermometer and verify that this is what you're doing. So you can generalize this to very far away objects and do the same thing. You look at the spectrum and see where it's peaking, and it's possible then to figure out the temperature.
And so the point of all this little bit of talking we just did is to give people an idea of the size of these numbers, because we predicted 5 Kelvin and we got the actual number was 3.
Yeah.
And yeah, that is what 66% off, but orders of magnitude, it's right on the same one.
Yeah. And when you're talking about a theoretical prediction, very often theoreticians, when they're making predictions, and if they're not working with experimentalists, they're not going to be caring about a number that goes beyond the first order approximation. So you can always improve based on whatever mathematical machinery you have in your theory. You can always improve on the precision of what you have. But if you're just trying to get the ballpark of where you're supposed to stand, it's always possible to come up with that initial estimate. And adding more terms is only going to be improving that result, depending, of course, on how good the model that you're using is.
If somebody was just going to use like intuition, like no mathematical calculation, and they were to try to like say what the background radiation temperature would have been, you might do something like, well, it's like the average temperature of the universe. So you might say, well, it's nowhere near 5 million and it's way above 0. I don't know where you would land it, but their mathematical calculation ended with 5. And like you just said, they only the accuracy level that they're expecting is only 1 order of magnitude. By the way, I don't think people know what order of magnitude is. So let's like I found out only people that study math know what that is.
Well, I'm not sure if we might have actually already discussed that at one point, and
I don't remember doing it. Order of magnitude just means like 10x, you know. So 5 million compared to 5, that's 6 orders of magnitude difference. And
yeah,
each order of magnitude is huge.
Yeah, you can also think about it in terms of scales. Like, for example, a typical human, a child might be about 1 meter, an adult might be about 2 meters. So that's going to give you a scale of how this is. A building that's 3 stories high is going to be about 10 meters. So that's 1 order of magnitude above the size of a human, and so on.
And so the point is, you know, if somebody said humans are 1 meter tall, and then you found a 2 meter tall human, you wouldn't say the guy was wrong. You'd say he was saying, you know,
yeah,
a range, and it's pretty close. Now, if you found a human that was 50 meters tall, then you'd say the guy was wrong.
Well, supposedly in Muslim mythology, Adam was, I think, 30 meters tall or something. And then for whatever reason, humans started becoming shorter and shorter.
By the way, I'm going to say something in line with that now. So I learned recently that humans before agriculture were about a foot taller.
Yeah.
And had bigger skulls, bigger brain, and some third feature I don't remember. And the concept is why we think it changed was we switched from a mainly meat diet to a mainly grain diet.
Yeah. Again, not my specialty, but what I know is that the heights of humans have fluctuated considerably, but not to that extent where
not what 2 additional orders of magnitude.
Yeah. So it's diet, environment, and of course, if you end up having certain populations being insulated from others, you can imagine that there's going to be specific averages of heights that are going to be characteristic of that group compared to another group. So
the tallest group would be in the area that that benefits from sweating. So in a very hot area like Africa, that would be the tallest group. The shortest group would be in a very cold area, which ended up happening.
I don't know. I wouldn't make such generalizations. I think it's more complicated than just that.
No, I'm not saying it's just that. That's one of the factors. I find that interesting, by the way. When I mention a factor, other people reply saying, "Yeah, but there's other factors." Yeah, of course there's other factors. Of course there is. Um, okay, where do you want to go from here? Did you finish talking about the history stuff, or
Well, if we want to think about the history, I think the history of this was interesting. We might have glossed over it. I remember we might have mentioned this at one point before that, well, it was in the preparation for what we're doing right now when the idea came up to do a podcast like this. So, um, the Big Bang Theory, as such, was not named like that initially. The initial idea was proposed by a Belgian priest in the 1920s. His name was Lemaître, and what he said was basically based on the observations that we have from the expansion of the universe. It seems that the universe was not at this size. It started from a much smaller size. So if you're looking at something that's expanding, the next obvious thing is to say, obviously, it started from something small. And the observations for expansion come from observations essentially that were accumulated by Edwin Hubble, looking at how fast things are moving. This uses the Doppler effect. I don't know if we want to delve into that. But basically, if you have an object that's moving, you can detect how fast it's moving. If you know its original color, and then you compare with the color that you're seeing as you're looking at it, you can see how much change there is in the color, and based on that, you were able to figure out how fast it's moving. What he saw was that everything was moving away from us, and so everything was shifted a little bit towards the red spectrum. There were some outliers, but on average, that's what you would observe. So as a result of that, this idea of an expanding universe, that's what Einstein objected to. And then came Lemaitre and established this new idea, doing some calculations. And again, this is a Jesuit priest. So he was thinking about this while having in the back of his head that there is a God and so on. But when he came up with the idea and he was talking about a cosmic egg and a primeval atom or something like that, many years after that, about 30 years after, Pope Pius XII basically took that and considered this to be a big evidence for what's described in Genesis. The idea of let there be light, the beginning that you see over there of the description of what happened at the beginning. Lemaitre didn't like that at all, and personally tried to dissuade the Pope that this is actually it's not a good idea to have this conflation between the theology and the science. This is something that's completely separate, and this is something that is definitely something that goes to the credit of Lemaitre. Now, Einstein, on the other hand, when he heard about this, he famously said to Lemaitre something like, "Your math is correct, but your physics is abominable," something like this. So he didn't like the conclusion, and yet after that, many years after that, he retracted what he said and he agreed with the theory, because eventually, as a scientist, once you have something that you agree with, the science, the measurements, everything is corroborating that. You have to say, okay, the idea that I had at the beginning has been falsified, and so I'm not going to keep clinging to it.
yeah, that's how Karl Popper explained it. He had conversations with Einstein, and Einstein said openly and many times, if the experimental result goes a different way, I will reject my theory.
Yeah, yeah. For general relativity, though, we have to say that there is not a single observation right now that contradicts general relativity. In all the scales that it has been measured. Of course, if you go to very small scales, the theory is not meant to be describing microscopic objects, and you have to include quantum mechanics. But at cosmic scales, it's impeccable.
Right, but it's, in my understanding, the fact that it doesn't deal with the small scale, that implies a contradiction between it and what we know about that.
Yeah, yeah. There are people who think that relativity has to be modified in order to accommodate quantum mechanics. Some people think that it's quantum mechanics that needs to be modified. Some people think that it's neither theory. Both of them are kind of an extreme case approximation of something that we still don't know.
It has to
But,
be that third thing.
well,
There's a third theory that when you pump in certain conditions, it pumps out general relativity and quantum mechanics, depending on which conditions you give it.
yeah, yeah, right. But what I'm saying is that it is possible in certain models that are being presented, it is possible to consider that one of the two theories is actually more fundamental and not just on the same footing as the
Right.
other, as just an approximation of a more general thing. In any case, we there are good arguments for each of the three scenarios. So it's an open question, and in fact, it's the biggest open question in modern day physics. Once you're able to have general relativity and quantum mechanics talk to each other in a kind of a coherent way, sit in the same
And
framework.
when was it that this happened? What decade where they realized this contradiction and this became the biggest issue?
Well, it there were indications very early on. So Einstein himself was trying to create a synthesis and was failing. In fact, until the very end of his life, he was trying to come up with a theory that combines all what he considered then what was considered then to be all forces. Um, Before him, in I think before it was before World War One. There were two guys, Kaluza and Klein, who combined relativity. Was it before World War One? I don't remember right now. Relativity with electromagnetic theory by adding a fifth dimension, and it sort of worked, but it didn't. So it was dropped, and then it wasn't until basically Second World War where people started thinking about a lot of math that was needed for the nuclear project, the atomic project, that's to say. That the math was sophisticated enough to show that there are certain problems that you cannot just brush away, and they had to be dealt with. And so quantum gravity was basically born very early on, but it wasn't realized until much later that this was really a big problem.
And you're saying it's the biggest problem. Yeah, it makes sense. It's the biggest problem to me. I don't know too much about. I also hear stuff about dark energy and dark matter, and I don't know anything about that stuff. I'm guessing it's the reason they care about it is that they think it would help resolve this issue.
It would help resolve so many different issues because uh, just from a theoretical point of view, if you're looking at um, one set of ideas governing a certain scale and another set of ideas governing a different scale, and they don't sit together in one frame work, this should not happen. If you're talking about one universe, one reality, there has to be some kind of a reference where it's possible to put the two together and have them work.
Kat is saying Philip Ball does something beyond weird. I guess it's some kind of YouTube channel, maybe. It is also something she recommends on quantum physics.
Yeah, I mean, there are plenty of people who rightly see that quantum mechanics is a very weird aspect of reality. And as mentioned before, we did not evolve to understand any of this. The fact that we're able to even have the math to make sense of it is actually something that's in itself very remarkable.
And by the way, it's a book, not a YouTube channel.
Yeah. So so after Lemaître, it wasn't some of the implications were not developed. Gamow was also one of the people. There was a host of names. I mean, we're not going to go into all of them, but there were implications of the idea of Big Bang that really convinced so many people who were skeptic, and that has to do with the way that it predicts the abundance of elements at the beginning. So if you look at the abundance of elements in the universe right now, you would see that it matches what you have from Big Bang nucleosynthesis, where you have about 3/4 hydrogen, 1/4 helium, and the rest is basically everything else. So according to the calculations that you would get there, you're able to predict that. And you're able to make certain predictions about the abundance of deuterium, which is not a very stable thing. Deuterium is one form of hydrogen that has an extra neutron in the nucleus. And so all these predictions together started making sense, and people in the steady state theory started fighting back, including Fred Hoyle, who is the one who actually coined the term Big Bang, and he was an atheist.
It's interesting that you say fighting back.
So,
in the context of this show about Islam and stuff, you say fighting back, but the fighting back you mean is writing a book.
Yeah, right. Definitely. Writing a book, going on a talk, and in fact, in an interview that they had with him on BBC, late 40s, 1940s, he was trying to defend his model, which was the steady state theory with that idea of matter being continually created. He, in a kind of a pejorative way, said it's something like it's inconceivable that everything is created in a Big Bang. And that's where the term was coined. Now, you have to bear in mind that at the time, atheism was pretty much related to remnants of things from the 19th century, including Marxist theology, which manifested itself in later on in the Soviet Union. The Soviet Union being a materialist society that does not believe in God, believes in an eternal universe. And so you can see in the Soviet Union, there was a lot of pushback also against something like Big Bang theory. So there was something theological right from the start. The fact that the Pope latched on this as if it were something that's corroborating his theology does say something about how Big Bang was perceived at the beginning. Now, later on, the term caught on, and the problem with it is that it has a really big misconception. It's a really bad word because usually when I look at the way that people translate it into Arabic, they translate it as the big explosion. They don't say Big Bang. I prefer to say Big Bang to preserve the error that we have in the picture that it conjures up. Because when you're thinking about a Big Bang, you have this localized explosion that starts from a certain point and explodes in space. What's actually happening here is that it's not an explosion in space, it's an explosion of space. It's not something that's easy to actually grasp because we always think about things in terms of space. But something like the Big Bang isn't actually happening within an already existing space. Space was expanding along with it. So the Big Bang is describing this period of really quick inflation that basically took something, say, that has a length of 1 meter, and since we talked about orders of magnitude, it expanded it to something that's 10 to the 26 within 10 to the negative 32 seconds.
Wow.
So we're talking about something that starts, say, with the size of an average dog. Within that small period of time, it expanded to something like 10, I don't know, in light years. It's astronomical. So
The size of a galaxy.
yeah. So we're talking
Within
about,
in less than a second, 10 to the minus 24 seconds, you said?
yeah. So this period was called inflation. There are many theories to actually justify that. The reason why it's stuck, even though it seems ludicrous to think about something happening so quickly at such a scale, is that so many of the observations, that the implications that we were talking about, the nucleosynthesis, the background radiation, all of these things are direct implications of this. So it's something that's consistent with it. Some people are contesting the idea of inflation and coming up with all sorts of various models, but inflation up to this point is the dominant model, that this happened so quickly.
I mean, it still inflated more afterwards, but it was a very quick inflation right at the start.
Yeah, but this happened so quickly for a very brief period of time that that it's not even comparable to what's happening right now. So again, this idea of the Big Bang being a localized event where it happened at some space, at some point in space, that's actually not true. Any place that you are right now in the universe, where you're sitting, the Big Bang happened. Where I'm sitting, the Big Bang happened. The Big Bang happened at a universe far, far away, if I were to quote Star Wars introduction. But yeah, it's something that happened everywhere. It's not, and so when you're trying to look at the way that people think about it, okay, well, uh, uh, where did that happen and how did it happen? Who made it happen? When you're thinking about it in terms of an explosion that we see in everyday life, people start coming up with these pictures, and that's why thinking about it as an explosion is really problematic.
Yeah. I don't know how to think about all the the space part of it, and I don't have a good handle of that. Like, because what I think of is stuff like, so there's an edge of the space.
Right. So this would so there are several ways of thinking about this. Some of them would have to involve in some way thinking about what came before. Um, Now, the problem with before here is that many people think that the Big Bang is the beginning. That's from a mathematical point of view and from a physical point of view, this is wrong. That's not how we understand it. The Big Bang is describing this period of inflation, but there's a period that we have a breakdown of our current laws where something like quantum gravity is supposed to come in and give us a picture of what's happening. So there is going to be a period within that 10 to the negative 32, the Planck time, that needs to have quantum mechanics involved in order for us to understand what's happening. So one theory is that there was no before, in the sense that if you're thinking about this as a quantum mechanical system, the singularity itself, the sharp singularity that you would get from general relativity, becomes smoothed out, and you have the possibility of quantum fluctuations at the beginning.
Something I heard, and I don't know if this means anything. One way to think about things is, well, time is events happening. So if there's no events happening, there's no time.
So right now, as far as we know, there are a lot of indications that space itself is not a fundamental aspect of reality, but rather a kind of an emergent thing. That's for space. For time, there are people who are saying things both ways. Some people are thinking that time is more fundamental, that it's not just something that you perceive, or like you just explained it, that it's a sequence of events, and that sequence is what results from this. Other people are saying that it's as emergent as time, as space. But yeah, time is a little bit more problematic than space.
David Deutsch has a theory called
Constructor theory, he has.
structure theory, and I started reading it. And I wasn't intending to read a lot of it. I just wanted to get a quick gist of what it is. And I had heard it before. I've been hearing it for 15 years. And something I read that's new that I didn't know before, not new to the theory or David Deutsch, but new to me. I didn't understand something before. It says in there, time is not inherent in the universe. So it's taking a position on what you just said.
Yeah. You can find people saying both ways. This is something really on the edge of what we really understand from the physics point of view, and as a result of that, you can come up with various scenarios that can do a lot in the background, but would be consistent with the final result, because the final result is so meager. What we actually really know about this is so little that we cannot really say anything for sure.
And when you say what we know, you mean the first 10 to the minus 30 seconds?
No, I'm talking about the nature of time.
Nature of time. Okay.
But even if you go and talk about that period of time, what actually happens when we're talking about the singularity of special relativity and how it's supposed to connect with quantum mechanics, the reason why we cannot go beyond that is because of that breakdown of our understanding of the physics, because we cannot put relativity and quantum mechanics together. So the Big Bang, as far as we're concerned, is not the beginning. It's it's not the beginning. It's actually the end of our understanding of what's happening there with the current tools that we have. And so that leads us to the next idea, which is the people who think, okay, what caused the Big Bang? That's a really big issue, because if you're talking about causality as we understand it, and go to quantum mechanics and start thinking about it, first of all, in quantum mechanics, causality is not a well-defined concept to begin with. But it gets compounded by the fact that if you're going to that beginning of what we think is the beginning of time, and you're talking about causality, and we tend to conflate that ontology with semantics.
That's like saying causality itself is not an inherent feature, and it's a emergent property.
Well, the problem with causality is that we tend to conflate ontology with semantics. So to clarify what I mean, when we usually think about cause and effect, we think about a cause as being before an effect in time. But we also think about the cause giving birth in some way to the effect. Now, if you're going back to a point where there is no time, it doesn't even have a meaning. Causality itself as a concept breaks down. It's not meaningful to say A caused B, because you don't have that sequence in time. So one person that, well, it's not just one person, it's Stephen Hawking and Hartle. They proposed an idea in the 1980s that gave an analogy of how we think about time. I might have mentioned that before, as when you're reaching the south or the north pole of Earth. So why is that a special point? In what way is it a special point? Yeah, you have something that has to do with the rotation of the Earth, but if you take the Earth outside of its orbit and just look at it as a sphere, there's absolutely nothing special about the South Pole or the North Pole. Now, why?
Also, another factor, it moves.
Yeah, so all of that created a kind of a special coordinate system that gave rise to the longitudes and the longitudes. The latitudes and the
Yeah.
longitudes. So what happens then is that once you reach those special points, that coordinate system breaks down. It's not something physical that's breaking down. This means that if you reach the South Pole and you say, I'm going south of the South Pole, it doesn't even have a meaning.
Yeah. Which direction?
Yeah.
Yeah.
So all
Yeah.
the
But if
points,
you were anywhere else on Earth and you say you're going to go south, you know exactly which direction they're going.
exactly. But each point can be chosen to be a south. And that's the breakdown of that coordinate system, because it has absolutely no special. So whenever you're talking about special directions, you're talking about breaking symmetry, which is a really big topic in physics. So we have a break in the symmetry because there was a special axis that was preferred due to the rotation of the Earth. If the Earth is not rotating, then all the points become equivalent.
I'm sorry, my mind went somewhere else because you said breaking symmetry is an important concept in physics. It's an important concept in epistemology.
Yeah.
The study of knowledge. Because a main thing that Muslims make a mistake of is they're considering a theory and there's multiple competing ones, and they're not doing what it takes to break the symmetry. So let's say you have a criticism of a bunch of religions, and so that criticism applies to all of them. Well, it doesn't help you break the symmetry between any of them.
Mm-hmm. Yeah.
So a lot of times what you see Muslims doing is something like, well, Christianity is wrong because of this criticism. Well, that also applies to yours, so that doesn't help you break the symmetry. You know what I mean?
Yeah.
Anyway, sorry for interrupting about
No, that's
technology.
Yeah. So with that idea, it's possible to have a bounded universe that can still have an infinite expanse, but no special point that represents a beginning. So that it's one model that's an attempt to resolve the issue, and it does rely on quantum mechanics a lot. But yeah, there are various ways to think about this idea of a beginning and to try to resolve this issue that you have between quantum mechanics and general relativity to come up with a way to maybe get a handle on what's before. You also have other models that talk about other universes that preceded this. So it's not inconceivable to think that what we consider to be the beginning is the end of something that was there before, and it's also not inconceivable to think that whatever event that initiated the current stage was violent enough that it prevented us from getting information about what was before. It's not that we have something in principle that tells us we cannot get information. It's just that at the moment, our information, for example, if it relies on visible light, it's going to have that cutoff at the 400,000 years. But we also have gravitational waves that are expected to be associated with the Big Bang event itself. Those primordial gravitational waves can go even before that, but we still haven't been able to.
Well, one of the ideas they're playing around with is that the universe is expanding, and if there's enough mass in the universe will be pulled back together, and we'll have a big crunch.
Mm-hmm.
If we have a big crunch, and you take a little bit further, maybe there's another Big Bang after that.
Yeah.
And it's just we're exercising.
And so one of the things I remember the first time I heard something related to this idea was in Carl Sagan's Cosmos. He was in an Indian temple, and he was talking about this idea, but in the context of Hindu theology, which has basically that same thing. And the nice thing about that theology is that it has a timeline that's also comparable to the actual timeline of the universe, compared to the timelines that we have in the Abrahamic religions. Of course, all of this has nothing to do with actual physics, but it's interesting for people who might say, well, look at the Quran or the Bible, they have this deep science. Well, go look. There are other theologies that by just chance came up with something that might coincide with certain models that are being proposed right now.
So we're an hour 11 minutes in. Have we? Did we talk about the history now?
It's a big topic. There's a lot to say about it, but we covered. I think we covered the history.
Enough of it, right?
Yeah.
Enough of it. So next time, I guess we're going to be talking about. Hold on. Where is it? Oh, let's see. Causality and the beginning. Can nothing bang? I think you already talked about some of this.
Some of it, yeah. I mean, the topics are obviously interrelated.
Problem of causality without time. We talked about that.
Mm-hmm.
No time before Big Bang. We talked about that. Quantum gravity and the softening of the singularity. Hawking's no boundary proposal. Did we talk about all that?
Yeah, that was what we just discussed. I mean, I'm not looking at the topics. I don't know what we actually.
That's all right. That's all right. You sent it to me and I kept it. So then we did 2 of the episodes that you and ChatGPT came up with just now. And the next one is God and the Bang, the theological take, which we touched on a tiny bit, but that's what we'll do next time, I guess.
Yeah. I mean that topic has also a lot of things because, probably we'll talk about this next time, but there are a lot of arguments that have been put forth across the centuries before physics, before anything, that have certain elements that current cosmology can say something about. Something like the cosmological argument, also the argument from design and so on, which has various incarnation today. So it's a very wide topic.
And then after that, what is nothing, and is that even a meaningful question? So that's the philosophical side of things, which of course the theologians, I guess they don't think about this too much.
They do. The problem, I mean, I don't know if we want to go into that right now, but so
tell me a little bit, and then we're going to get into detail later, 2 episodes from now, about it.
Okay, so in all of the Abrahamic religions, I cannot really say much beyond them, but in all of them, if you look at the creation myths, you will see that the God figure doesn't actually create ex nihilo, does not create out of nothing. The God starts with something that already exists. But what happened in the Middle Ages was that the theologians started coming up with this idea of creation out of nothing, which has nothing to do with the original scripture. If you open a scripture right now, whether it's the Bible or the Quran, you will see that God
made the universe out of something that was there already.
Exactly. And so it is problematic for that reason. But they needed to give that more sophisticated God the ability to create out of nothing, because otherwise you would give the God a kind of an inferior stage or state compared to whatever that's existing.
So they realized how shitty their argument was, and they tried to give God some more power, so it wasn't such a shitty argument.
Well, I would say they discovered that, and they tried to patch that God, or to patch the theory of that God. And they ended up with basically 2 different types of gods: the God that people in everyday life worship, and the God of the theologians that basically exists in a completely different realm that's supposed to explain very different things.
So the other question I think we should also consider, a philosophical question. What people ask oftentimes is, who made the universe? Who made the Big Bang? And there's an assumption in the question itself that there is a who. Because the who part of it is like saying it's personifying whatever made the universe, if anything made it, and saying, huh?
Who done it?
Who done it? Who meaning like something like a person.
Yeah.
Something that has agency, will, preferences.
Yeah, exactly.
The wish to be worshipped. Which, by the way, I wasn't saying necessarily humans have that. I guess some of them do. Right? Some humans have that. The wish to be worshipped.
I guess.
I mean, that's what Pharaoh was.
Well, here's the thing. If there's anything that's attributed to God, it must have some analog in humans. We created the gods in our own image. So you should expect that someone wants to be worshipped. It means a person at some point, or several persons want to be worshipped.
Yeah. All right. So what do you think? Do you have... I don't have any housekeeping issues. Do you want to end it here? Do you want to talk about anything? Do you want to talk about June 14th?
I don't know. I mean, if you have certain things that you'd like to discuss.
No, I don't think so.
Okay, I'm looking at the comments right now.
Oh, maybe we should put up some of the comments. Muhammad Islam says, all galaxies used to live inside Jannah. Later, those got kicked out. Shukran ya Iblis, Al Kareem, Al Mubarak, Al Hakim. Hakim. What does Hakim mean?
Wise.
Wise. And then I don't know what this is about. Look at the cone diagram, please. I don't know what that's about. I don't know what that means. And somebody asked if we're live or pre-recorded. I don't get that. So I told him. Kodasling on the planet is the heart of a mu'min. Let's be fair. There's good ones that have, good hearts, and they don't want the death penalty. And
yeah, I mean, we're all humans, and at the end of the day, when you're looking at the people who might believe some of these things, very often it's because they don't actually have face-to-face interaction with a non-Muslim to actually create that human connection. But just demonizing each other is just useless and not fruitful.
Kat was correcting us on something. When I said that we had a meat diet before agriculture, she's saying that's a myth. I'd like to hear details about that. I'm not sure if she's here anymore.
I mean, the
hunter-gatherers ate what was available.
Yeah, exactly. Yeah, I was going to say about the hunter-gatherers.
All right. Oh, and there's another thing. When she was talking about the and she's here. When she was talking about the Philip Ball's Beyond Weird regarding quantum physics, she's clarifying it's more about the attempt to go past seeing quantum physics as unrelentingly weird. So trying to make it not weird.
I mean, we are living in a quantum world. The fact that we just perceive it as weird it has an inherent contradiction. It's like you're looking at the table in front of you and seeing that table as weird, even though it's a commonplace thing. You might have been the person who put it there, but at the same time, if if quantum mechanics were not weird, why didn't we come up with it intuitively? Why is it that we had to search so hard and to stumble so much and to have so many smart people, including Einstein himself, who was one of the people who initiated quantum mechanics, and yet he completely rejected it until almost the very end of his life. So I don't know. I
Well,
think
we don't see quantum level effects when we're growing up, 1 year old, 2 year old, 3 year old.
Yeah.
Like, right? We don't see those. But we, through our five senses, we do engage on the macro level scale of things. So like when we first learn about gravity in school, we already have a whole bunch of observations for the previous years of living your life. But then when you try to learn about quantum mechanics, you don't have anything in your
right.
observation.
I can go more extreme than that. Think about Newton's first law. So Newton's first law is a very simple statement that tells you that the natural state of an object is for it to be either at rest or moving with some velocity. That second bit is very problematic and very counterintuitive because of friction. In everyday life, friction is everywhere. And so to see an object moving on its own without being pushed is not something intuitive at all. And yet it's meant to be one of the really fundamental concepts of classical
How did he
mechanics.
notice that without?
How
did he? Doesn't that mean he recognized friction was there?
Yeah, but it was mainly Galileo who was the one who conducted the bulk of the experiments that led to that. So the first law wasn't just Newton sitting in his room and coming up with something. There was a series of experiments, including experiments that were done by Galileo. But that's the point. In everyday life, we don't see the first law as something that's true. So much so that Aristotle, who was thinking within that intuitive frame of reference that we have for everyday life, had a version of the first law that said something that's completely ludicrous from the point of view that we have today. He said that the natural state of things depends on where they belong. So the natural state of a rock or a heavy object would be to fall down because it's made of earth. So it's going down to earth because it's of the same element. So things of that sort. And so because of this, you end up with a need for a first mover in order to counteract the contents that you would have in the first law. So the first law is saying that you don't need to sustain an object in motion in order for it to be in motion. With Aristotle's picture, you actually have to. And so you need a first mover. You need a god, what people considered after that to be a god, in order for this to be the case, to sustain that existence in being. And in fact, if you look at a lot of Christian theology, they talk about God's interference as that instant continuous interference in order to sustain existence in being what it is, because they were generalizing from our everyday experience.
Yeah, so I find it very weird. I remember I took a quantum mechanics class in college. I found that all that very weird. Some of it was very simple. But yeah, just where it seemed like the physics of the first year and second year that we learn in school and in high school or whatever. I remember very early in my life, like all the stuff I was like, yeah, I already knew that. Like, you know what I mean? Like, because you've seen things like that. You could almost come up with stuff even on your own. I remember inventing the electrical motor in class as the teacher was saying, so imagine this and imagine this, he was just explaining let's say if you set up the electric motor in a certain way, what you could do with it, but he hadn't said the motor yet. He goes, do you guys know what you could do with this? And I raised my hand, electric motor. And I invented it like in the class. And invent doesn't mean I'm the first one, obviously. And to be clear, when you learn something, you're reinventing it in your mind.
Yeah.
Everyone has to reinvent everything.
Yeah. Let me just say one more comment about that issue. So I'm not saying that it's not possible to cast quantum mechanics in a light that makes it more familiar. I'm sure that there are many capable people who are able to produce it in that way where it makes a lot of sense. But I think there's something that's irreducible about its counterintuitiveness, about a lot of the things that it implies, whether it's genuinely something that cannot be reduced to anything else, like what people think right now, or if it can be reduced, and you have what Einstein called hidden variables that eventually you can show are there, that are showing a missing picture. Once you have that missing picture completed, you can have a full understanding of the situation.
So one of the things, I don't know how I thought of this. I guess I'm thinking of like barriers of our knowledge, or looking at extreme cases to try to understand something. Sight, which is our biology that is trying to, I guess, measure or a physics concept, okay, light. And then you think of questions like, okay, me seeing you, even if we were in front of each other, physically in front of each other, technically speaking, I'm not seeing you now, I'm seeing you in the past.
Mm-hmm.
Now, because we're so close, you could see it as it's right now. Okay? And even though there's a lot of steps in between now, the light has to travel, well, from somewhere else, hit me, get to the camera, electrical things happening in between, through the internet, get to you, and then it has to be shown on your screen. We can still almost see that as now too, although a lot of times you see a little bit of a delay, half a second or something or more. But then if you go further beyond into more extremes, let's say we're thinking about a faraway planet in this galaxy or in another galaxy, and now you can't think about it as you see something and it's happening now.
Doesn't have to be galaxy. If you send something to Mars, it's going to take a few minutes for the signal to get to us.
Yes. Minutes, though. You can still hold a conversation that way. Yeah. So if we're talking about the moon, somebody's on the moon and they want to communicate with us, how many seconds is that of a delay?
Few seconds, 8 seconds. I'm trying to think.
To the sun, it's 8 minutes.
Yeah, it's 8 minutes to the sun. I'm thinking to the moon, it's something on the order of 6 to 8 seconds.
And just, if people don't know what we're saying here, that's how long it takes light to reach from the sun to us. So if I look at the sun, which I shouldn't, nobody look at the sun, please. You look at the sun, you're seeing it 8 minutes ago.
Yeah.
So if you pick a, let's see, how far do I want to go? If you pick a galaxy that's far enough where when they're looking at us, they're actually seeing dinosaurs, not us.
Yeah.
So right now they're receiving light from Earth that bounced off a dinosaur 70 million years ago and is now reaching a galaxy or a planet 70 million light years away.
Mm-hmm.
Saying that right?
Yeah.
And they're receiving it now, and they're like, "Oh, look, those guys are a bunch of idiots." Still, well, it's not humans. They're not seeing humans. Of course, they would already know that. They know about the 70 million years issue too, right? So they know they're seeing us in the past. All that stuff is very interesting to me, and So back to the biology of it and what we're seeing. Light rays coming in. Is it particles? Is it waves? Hitting my rods and cones. I don't know where I was going with this. It's all very weird. Even the basic stuff.
Yeah.
Even the stuff that is kind of that I was saying earlier, macro scale things that we can sense. Even that stuff breaks down. You gave the example of the friction, of what would you call it? Inertia. Things are either at rest or moving at their current velocity unless something stops it, unless there's an external force to stop it.
Mm-hmm.
Missing the, what we see is friction everywhere. Although there's edge cases still even there, because like if you're watching someone ice skating, I wonder how measurable, how much friction is there. It's pretty small.
Yeah, but if you want to,
go ahead.
Yeah, I'm sure people who are thinking about that consider this, but it's such a special case that it doesn't match with what you have in everyday life in all other situations. They also probably knew that if you put a layer of oil between two surfaces, they're going to be moving much smoother against each other. It's not that they weren't able to see a world without friction. It's just that when you're thinking about an object being pushed in a natural situation, the tendency would be to say you cannot see it moving on its own beyond a certain limit. You have to keep pushing on it in order to sustain it in motion.
I wonder if we can think of some more examples like that. Things that we maybe initially think is very intuitive, and then you find out as soon as you look at some edge cases, it's not very intuitive.
There is something. It's probably the central question in philosophy. Why is there something rather than nothing? Once you hit that wall of looking at why is there something rather than nothing, that turns everything that you're looking at as weird, because you start looking at things not just as a computer, a table, a bottle. You're looking at things as existence versus your consciousness, and I think that in itself is really weird.
Why is there something versus nothing? What's that have to do with our consciousness?
It's not something that has to do with our consciousness. When you're looking at all of these, and you are the subject that is considering this question, that's where your consciousness comes in. But the connection was to our initial topic of the Big Bang, because eventually you're going to be hitting that wall. Whether you're going to say there is a God, there's no God, there's something that initiated the Big Bang or not, you have to even explain that thing. And as they say, it's turtles all the way down. Otherwise, you end up with.
Why is there something versus nothing? Is that asking why is there something that made the universe versus nothing that made the universe? What is it?
Why is there something existing at all?
You mean why are we here versus nothing existed ever?
Yeah, and that includes usually talking about why are there physical laws in the first place? Why is there a void or an empty space-time to begin with? So, I mean, you keep removing things, and you still have that sense of that seems to be a natural state of things, and yet you see that it's actually occupied with other things. How do you explain the presence of all these things?
So in physics, are we really answering any why questions? It seems like we only answer how does this thing happen questions.
Yeah. So if you want to really look at not just physics, but any kind of science, what you're really doing is describing things, but you're not really explaining things. I don't know in terms of what.
It seems like not a meaningful question. Why did something happen? And I mean in physics. I'm not talking about humans. Why did the universe start? That seems like a meaningless question. It doesn't make sense.
Well, I think
it's still making that implication that there's a being with the agency decided it.
Yeah. So when we usually ask that question, we're talking about intent. We're assuming that there is some kind of intentionality, and
right.
That's why people say that see teleology everywhere, that there is some kind of a purpose for everything. And very often what happens in science is that you convert that why question into a how question. Once you break apart a certain phenomenon and understand how it works, very often the why question disappears. And so you might push it back one level, understanding how the rain works. It's no longer related to some angry god who drives the clouds or whatever and sends light bolts. It's going to be related to the mechanism of how the rain gets created and all the action that's related to evaporation, electricity, and so on. So it turns into a how question. It's no longer a why question.
And for any of the constants that we have to put in any of our formulas to make shit work, and if somebody was to ask why that constant instead of another one, that's not a meaningful question.
So if you look at something like, say, the mass of the electron, the reason why a why question would appear in that case is this is a very particular value. If you pick any electron and measure its mass, it's going to give you that same mass. Why the hell does it have that particular mass? So there is something that requires at least an explanation of the mechanism why it acquired that mass, or something, some kind of a sequence of events or phenomena that led to it having that particular mass and not a mass that's, say, 1% more or 1%.
So that's like saying how it got that mass.
Yeah, that's eventually it. And so one of the things that we're going to be talking about is fine tuning, which exactly dwells on our lack of understanding for the mechanisms for many of these constants. So because we don't understand how this arose, we're going to say that some kind of an intelligence is turning knobs and choosing these for some specific purpose.
So let me tell you something about that real quick. Suppose that, well, let me take a step back, actually. We said maybe the universe was doing this, okay? Like breathing.
Okay.
But also maybe there's many of these happening far away from each other.
It's possible.
Okay. And maybe there's an infinite of these.
Okay.
Okay. And maybe every possibility of constants is represented in here. Okay, so we're just one of them that has the perfectly fine-tuned whatever which generated us, and almost all the other ones don't. And if you ask why this one, not the other one, well, those didn't produce any beings that could ask the question.
Yeah.
And then this would bring to shambles anyone's conception of, this line of logic leading you to God.
Yeah, so that's exactly the idea of the what's known as the anthropic principle. It has various forms, but yeah, that's one form of the anthropic principle. The assumption is that you have this wide array of possibilities for what can be considered as a many or multi-universe, and then the ones that are going to be populated are the ones by definition that are capable of hosting intelligent beings to populate them. There are reservations on this. I don't know. The theory does actually have some justification, some theoretical justification, but it's still a very extravagant theory in terms of what it needs to assume in order to satisfy these basic ideas.
That's another episode or series, fine-tuning of the universe.
Yeah, I mean, this is the problem with it is is really based on a basic misunderstanding of the physics and making certain taking certain assumptions for granted and flying with them and building to fit whatever the ideology needs.
Hey, let's talk real quick. I have some new ideas for episodes. Here's one called Doubt. Do you doubt your decision to leave Islam? This is a this form of this question was asked in the ex-Muslim subreddit recently. So I think that's worth talking about.
Yeah,
Another one, Sharia law. Do Muslims want it? Do we have reliable statistics? I want to talk about that, and it's going to land with basically saying, look, most people who say they want it don't even know what it is.
Yeah, I think the question is phrased without really knowing what Muslims typically mean by Sharia.
Here's an episode Zorro and I thought of, and I'm not sure I want to do it. Stupid things we did when we were Muslims, or things we thought too, and I'm not sure I want to do it.
Well, maybe he can take the lead then.
Who, Zorro?
Yeah.
I think it was my idea though. He would say I have to take the lead. Another one. Sharia law, does it contradict human rights or not? I've been watching Maryam Namazi a lot, so she talks about that a lot.
Mm-hmm.
Let's see. I think that's it for new ideas for episodes.
We still have plenty, and I'm not worried about a lack of topics.
Sure. And I started a new thing. Let me put this on the screen real quick. Let's see. Let me make this smaller. I'm trying to get people interested in another episode. Let me put it on the screen. And I'm doing it a little bit differently than before. So it's about miracles. We're planning a series of episodes on deconstructing Islam. And I just tell people, that we're planning this. What would you like us to talk about? I give some examples. I mentioned you're an Arabic speaker, so we can analyze the Quran and Hadith if needed. I tell them to comment below on this Reddit post. You're welcome to call in. First come, first serve. We're prioritizing ex-Muslims and doubting Muslims, but we'll talk to everyone. And then I'll update the Reddit post when we go live. And so I tell them to follow the post. And then I say kind of an example of what we're going to talk about. Miracles are nonsense without even considering details. And hopefully we get some engagement that way. I'm just trying to connect more with the existing ex-Muslim Reddit audience, which is supposedly 194,000 people. So
I can say a lot about inflated numbers, but yeah.
Say it real quick.
Well, I've been an admin in groups where you have this. You would have 90,000 people officially registered, but when you actually look at the statistics of people who are truly active, at best it's usually 5 to 10%.
Yeah, and I thought you were going to say some cheating, but it sounds like you're just saying, people got in, they were interested, they're not there anymore, they're doing other things, but they're still a user and still a...
There are some people, I think what happens sometimes is that you have people that basically like to follow silently sometimes without really engaging. Some people just register and just not come back, essentially just maybe planted a flag here to get back to this and then forgot that they even registered. You can come up with all sorts of scenarios, but I'm telling you from my own experience is that you look at people registering, they file requests, you admit them, but then the actual number of people who really participate, who make comments, who create posts and so on is very little.
Well, the part I'm trying to say is something I hear from other groups. It's a support group in effect, and support groups that have been created around something they were leaving, a cult or whatever, a religion, anything. The initial group of interested members, after a few years, well, their issues are resolved. They don't need this support group anymore. They leave, but their numbers are still there technically. And new people may come, but the new people don't get the same experience as the original group. And the support group dies. completely dies.
Yeah. So if you want to think about this in terms of as a support group, if you have some kind of a rehabilitation taking place, it makes sense that there is something that has to be permanent or constant there to drive the whole experience, whether it's some kind of a group that represents the staff that creates that basic support, or some of the former members who continue on. They believe in this as a calling, a cause, or something of that sort, and so they stay there in order to support the others. But yeah, I think many of the people who get what they want, what sort of purpose would they serve if they're going to stay there? Uh, uh, Especially if you're thinking about this from the point of view of someone who thinks this as a transitional period and they just want to get back to their normal life. Um, but to say that this is happening as a matter of course, I don't think that this is necessarily the case. I think unless the period of time for that initial group was so small that the momentum that the group has was lost completely.
Well, I guess I'm imagining groups that are, well, in-person groups. I don't know too much about, because online kind of changed things, and I was thinking more in-person groups, or in-person and online combination groups. They're local, they meet up, and then after about 5 or 10 years, they're not doing meetups anymore. They still have the online. The event is happening. Come show up, but all the people that found it helpful when it started, they don't need it anymore, and they don't really want to talk about it with new people.
Yeah.
Hopefully that doesn't happen to the ex-Muslim community overall.
Well, I think there's another issue that needs to be taken into account. The fact that we don't have a stable situation. The past 20 years or so have seen so many different changes that you cannot talk about a cohort that is basically the same as the one that's next to it. So each consecutive generation is bringing a completely different set of concerns. And so sometimes the overlap that you have between these cohorts doesn't actually make a lot of sense. So it's like you're talking about two different groups. I cannot say that, for example, the turnover period is, say, 2 years, for example, and then after that you're going to be getting a completely different group. But what I do know is that things are changing continuously.
Yeah, so as an example of what you're saying, what I heard is like 10 years ago or a little bit more, there was a void of any online presence of ex-Muslims, pretty much.
Yeah.
And then when that got filled, how do I say this? So like in 2008, the Council of Ex-Muslims of Britain started, and they did an event in their first year trying to gather ex-Muslims, and no one showed up except for the initial 25 official members that started it. And technically they did show up, but they didn't want to show themselves. And then the criticism they got was, come on, are there really any ex-Muslims? No one showed up. And that has changed a lot. Now there's people popping up all over the place, groups and YouTubers, and
yeah.
So yeah, it's very different now. I don't know what that means for, what effect that has, and how that makes things different now than 10 years ago. I don't know too much about what that would have changed.
I think it's again, like any thing that's involving humans, this is a multi-factor thing. It's really hard to pinpoint it unless someone is doing some kind
of as an example of a thing. Okay, I remember Zorro telling me, and I heard this from other people, like the guy who started Atheist Republic, Iranian guy.
Mm-hmm.
I forget his name.
Armin Navabi.
Okay. Both of them said the same thing when they became atheists. they thought they're the only ones because they didn't know any others.
Yeah.
I didn't have that feeling when I became an atheist, but I was living in the US. This happened to them in a Muslim majority country.
Yeah.
So I wonder if today anyone would think that they became an atheist and then think I'm the only one. I don't think that's the case. Probably because the way they became an atheist was they were seeing people like us.
Yeah.
And like
the threshold right now is so low for any internal doubts that someone might have, that it can easily push people over the edge. But at the same time, because of the fact that the threshold is so low, it's also possible to hop back. This means that I don't want to say
Dawa guys.
Well, no, I don't want to say it this way, but that would mean that the population that you have for people who are ex-Muslim is now so varied that you have people who really went through a process, and there's people who might actually just be harboring doubt and just feeling something that might be cleared up from the perspective of the religious people with a small a religious crisis that can be resolved after a while. Maybe if you pray enough, maybe if you go to Hajj or whatever, you can actually resolve it. So now you have that kind of range of people, unlike what we had before.
You know, a similar thing happens in lots of other things. If you look at if you go back, let's say 20 years, and you look at the distribution of gamers, online or, computer games, it was generally very high interest people wanting to play very difficult games. But if you look at it today, that's a very small percentage of the gamers. And it's now mostly people that are kind of just want to play for fun and just, and the fun isn't competition. It's kind of more like wasting time. Maybe wasting time is not the right word to say there. I do that a little bit with some games on my phone, but the gamer distribution is very different from when it started to what it is today.
Yeah.
And that's what you're saying about the ex-Muslim community.
Yeah. Yes.
Interesting. Okay. All right. I think we should stop here. We're almost at 2 hours.
Okay.
All right. Bye, everyone. Take it easy. Stay on if you want.